Alright, so I'm actually going to skip number 2 because I really want y'all to think about it. There's not much calculation in there. It's just really comparing those two forces. And if you look at the force that we calculated on Thursday, you can compare the force of the sun and the earth and the earth and the moon. And it's really neat because the moon and the sun, as we know, are pretty far away. But that sun is really, really massive. So just compare those two forces and you should be able to answer it in a complete sentence. So, number 3. There is a proton and an electron in a hydrogen atom. Each have a charge of 1.6 times 10 to the negative 19th coulombs. They are placed 4.0 times 10 to the negative 8 meters away from each other. Is there an attractive or repulsive force? Well, for this you have to remember that protons have a positive charge and that electrons have a negative charge. I hope I didn't say that backwards. But as you can see here, I'm drawing it out. Now, since they are opposite charges, they want to attract each other. So, it is an attractive force. And why? Because they have opposite charges. Now you can go ahead and write that in a complete sentence. For the calculation for B, we have calculate the Coulomb's force between the charges. This is the electrostatic force that those charges are experiencing, that push or that pull. Now our formula is Fe for electrostatic equals our Coulomb's constant, K, times the size of each charge, all divided by d squared. So, we know K, we know each charge up here, and we know the distance between them. So we should be able to go ahead and input that information. So K is 8.99 times 10 to the 9. Now let's make sure we put our units. Newtons, meters squared, coulombs to the negative second. Now Q1 and Q2 are the same, 1.6 times 10 to the negative 19 coulombs. Now it is squared because there's two of them. I just don't want to write it all. And just if you don't remember, coulomb is the unit of charge. So they are placed 4.0 times 10 to the negative 8 meters. But we have to make sure and square that. So it seems that we have everything ready to go to Desmos and go ahead and plug that in. So we have, again, I'm going to use parentheses to keep everything together. 8.99 times 10 to the 9th. And then I'll move over, put a parentheses, and I'll open a new parentheses. For the first charge, or for both charges, it's 1.6 times 10 to the negative 19. I'll move over and I'll put my parentheses. Now, don't forget that there is two charges, so you will square them. And then finally, we divide by that distance that they're separated by, which is 4 times 10 to the negative 8. 4 times 10 to the negative 8. And I forgot my parentheses, so I'm going to go back and put those in. And then finally, that is all squared. Now that gives us an answer of 1.4384 to the negative 13. And as we will see, it is newtons. So I'm actually going to write this right down here because I wrote kind of big. So we have 1.438 newtons. That is our answer. To verify that it is newtons, we see that there's meter squares down here, so these two canceled. Now this negative 2 and these positive squared, sorry, Coulomb charges cancel out, and we are left with newtons. Alright, that's it.